guys, this is the question from the CF Educational Codeforces Round 5. And the question is the Labyrinth. And I would like to ask you one question. Do you actually know the meaning of Labyrinth? If you're not, so let's try to guess. I'm drawing something. Okay. So this is the one. Look at it. Are you trying to guess something? Pardon my drawing, huh? Because it is really bad. Okay. Just try to guess. Yeah. Do you get some idea? Like, I'm giving more hint like, you are here, you can move here. You can move from here to here. But the thing is that you will remain trapped in it. What we call in Hindi, guys. You're right. This is Bhool Bhulaiya, right? So let's come to this Bhool Bhulaiya question, guys. Okay? Yeah. Let's come to the question. So question says that you are given a rectangular field of n cross m cells. Okay. I'm given a rectangular field of n cross m cells. Fine. Each cell is either empty or impassable, contains an obstacle. Okay. So what is saying that cell is either empty or it cannot be passed. Like it is an obstacle. You cannot pass through a cell. Okay. Okay. Empty cells are marked with dot. Impassable cells are marked with star. Do you understand that? Dot represent in the grid is empty cell and a star represent the impassable cell, the cell you cannot pass. Okay? Right. Let's call two empty cell adjacent if they share a site. Yeah. So when do you call the two empty cell are adjacent cell? If they share a site, like here. You can say that this cell, okay, and this cell are adjacent because they are sharing a site. Similarly, this cell is adjacent with this cell, right? So you can say in left, you can say in right, you can say in top, you can say in bottom. So this is the way you can say that the cells are adjacent, right? Yeah. Let's call a connected component, okay, any non-extensible set of cells such that any two of them are connected by part of adjacent cells, right? And it is a typical well-known definition of connected component. Obviously, when do you say that the cells are connected? Look at this. If you see that, if from this cell to this cell, I'm moving, right? So can I say that this cell is connected? Yes, you can. Similarly, we can say that like these cells are actually more precisely, can I say that these cells are connected? You can move from here to here to here. Obviously it is an obstacle, but I'm showing a general example that I can say that these cells are actually connected, right? Exactly. So what I need to do, I have given with an impassable cell xy, I need to imagine that it is an empty cell. Okay, so I will fill with dot of it. Okay, fine. And all other cells remain unchanged. And I need to find the size or number of cells of connected component which contains xy. Oh my god. So what the question is telling that I have given an impassable cell, and I will do it for each impassable cell independently. Okay. So what I need to do when I have an impassable cell, like this is an impassable cell. Okay. I will need to first fill it with dot, and then I need to find that in which it will be, then it is a part of a connected component of dot, right? Exactly. Look at this. If I make this cell dot, then this is a part of this connected component, right? And you are clearly saying the output is 3. Why? Because it is becoming the part of this connected component. If I like to show you, this is the one, this. Oh, if I just highlight it, that is better. Yeah. Uh-oh. Sorry for it. Uh, let's think a bit, guys. Yeah, it's causing a bit problem. You can understand like this corner we are looking for, okay? So this become like 3. Yeah, that's a one. That's a reason. Okay. Because I fill with dot and it is a part of become the part of this connected component of the dot empty cell. Yeah, look at this. What is telling that find the size of uh, connected component which contains xy by imagining that it is an empty cell. So basically the connected component is what? A dot cell, an empty cell is connected to empty cell, right? Because we cannot pass through impassable cell. So that is what we are telling, that we need to find the connected component of it. But the connected component is the one that is made of the empty cells by filling the impassable cell as dot. And I need to do for all impassable cell. Okay. Now let's read more. There is a suggestion given, guys, that the answer should be printed as a matrix with n rows and m column, obviously, and jth column of ith row should be dot if the cell is empty at the start. Okay, so I have not touched need to touch like empty cell. Okay, I don't need to touch empty cell. I just need to work with the impassable cell. Okay, otherwise, the jth symbol of ith row should contain only digit. Answer modulo 10. The matrix should be printed without any spaces. Okay. So what do you mean by answer modulo 10? Basically, if it is an empty cell, I will just print dot. But if it is an impassable cell, then I know the like what is the size of the connected component of it. So I will print that of it. Okay. With the modulo 10. Right. Yeah. That is what it's telling. Also, it's telling that to make your output faster, it is recommended to build the output as an array of strings having length m and print it as a sequence of lines. Okay, and it will be much faster than writing character by character. So basically, it is telling that when we are using the vector of character to store the like n into m and print it like as a vector of character, instead of that, if I use the vector of a string, then that will be much faster than compared to vector of character. Okay, yeah. And another thing it is telling that as input output can reach huge size, it is recommended to use fast input output method. For example, prefer to use scanf, printf instead of C in C out in C++. Prefer to use buffer reader, print writer instead of, so it's a generic thing like as we use in C++ like iOS Sync Studio, like iOS Sync Visual Studio. Yeah, that's what we use. C in dot tie 0, C out dot tie 0. That's a general thing you use. That is a fasty. Yeah, in the fasty we already use in template. That's what it need to telling that use that so that like you say it will become faster, right? So that is what it basically telling in general. Okay, now what is the input format here? The input format is like two integers n and m, and n will be representing the number of rows and column in the cell, and each of the next n and m line contain m symbol, basically empty, basically the grid. Yeah, that's it. And what is output? Output the matrix as shown. So like as described, yeah. So as I already told, like I need to output the matrix. If it is a empty cell, I'll just print dot. If it is an impassable cell, I'll print the size of connected component modulo 10. Okay. Now, what do you think, guys? Look at the constraint like nm like 1 to 1000. Okay. So if I look for the logic of it, let's look for the logic of it for once. Where? Yeah. So, okay. So if I look for the logic of it, then I'm getting a certain idea. Like I am thinking, let's say that what I'm thinking. Okay. So I'm saying that I have what do you say? I need to run basically in O of n into m. Can I say that? Yeah. Why? Because like n is a power 3 and m is also power 3. So somewhere I need to like n into m will be the precise choice, right? But I'm getting idea like I cannot run it in O of n because I need to go through all like cell, right? Can I say that for each cell I need to visit all the neighbors of it? Can I say that? Why? Because like if I not visit all the neighbor, how can I know that the connected component size of it? Yeah, that's true. So in that sense, I'm getting something like O of n into m square. Oh my gosh, that will not work, right? If I go for O of n into m square, my constraint will be somewhere like my time complexity here becoming 10 is to power 12. I really need to do something, right? So what I need to do? Can I think of? Like if I just say that, mm, one idea definitely I know that I need to use here flood fill strategy. Can I say that? Yeah. Obviously, because I need to explore in all direction. For each cell, I have to move right. I need to move left. I need to move top. I need to move bottom, right? So I'm moving in all the four direction as per the definition of the adjacent cell, right? And as per the definition of connected component, I'm moving like this. I can move like this, something like this. Can I say that? Yeah, that is a point. So that is a point here. So obviously I'm getting that this we are given with the what is this guys? N into M cell. N into M cell is basically your adjacency matrix. We are not given with here adjacency list. We are given with here adjacency matrix. So we clearly see that we need to use the BFS here to basically find the number of connected components, right? Exactly. To find the number of connected component, I will use BFS definitely, and that BFS will be your like adjacency matrix version. In general, we can say that that is a flood fill strategy or like boundary BFS strategy. So we proceed here with basically, in general, if I need to write, that is, we proceed here uh, with the flood fill strategy. So the point we get that I need to use here flood fill strategy. Okay. Now the point is that I got to know that I need to use a flood fill strategy, but I also know that I need to maintain the complexity of O of n into n. So what I get the idea that let's first calculate the connected component for all the cells. Obviously, I will not calculate for the impassable cell because I don't need that, right? So what I did that for all the empty cell, we will first calculate the connected component size of it. Okay, so that we can do it in O of n. So pre-computation will do it in O of n for all the empty cells. Okay, not the, yeah, but like we are calculating for all the empty cell only, not the impassable cell. And then we know that what is the empty cell size, like what is the component size for empty cells, right? Yeah, so that's what we do. And after that we iterate over all the cells again, because once we already know that what is the empty cell size, then we iterate over all the like what do you say, this star impassable cell, and I'll fill that with dot. And once I fill that with dot, I will like try to find the connected component size by again applying like BFS there, or somewhere like exploring the all the neighbors. Then we can get that like uh, basically the connected component size of it. So overall we can get that the complexity come out as O of n into O of n, like O of n into m plus O of n into m. So overall like O of n into m. So reliable complexity, right? Yeah, reliable complexity we get that is easily passed, and yeah, that will easily run. So this is the logic here for this question. Okay, so let's come to the code part of it. Okay, so let's come to the code part of it, guys. Yeah, so let's take a template. So if I come to the code part of it, so what I look for is that I'm given with the mn. So I'll taking the mn, and now I'm taking the grid as the input. So that's what I'm doing. I prefer vector of character instead of a string because it's easier for me to handle. All the question is told explicitly to take vector of a string, but I believe that does not cause a much problem, so it will run safely. So somewhere if not there, then prefer to use vector of a string, but I prefer the vector of character, and that's why I am using that because I am more comfortable in that. Okay, yeah, thank you for it. So grid mn will be declared. Now we're taking the input here. So that's it for it. 1 second. Yeah. fine. Get it? Like, yeah. So our input part is now complete. Can I say that? Exactly. So this is debug it. We're taking time, no? Come on. Yeah, input is done. So now, as I already told you guys, I need to first do the pre-computation for basically the component size of it. And for that, what I do, I will mark the component ID, like basically component ID is your group ID, like component number ID, that which component it belonging to. Okay. So I need to like take care of two basically state, you can say, that is one is your component size. The what is the size, the cell is the part of a certain component, right? So what is the size of that component? That's what we need to take care of it. And another thing I need to take care of it is that what is the component ID of it? Like for a cell, the component ID is there. So we'll find the component ID of it. So we'll first do the pre-computation, guys. And since we are using the boundary BFS strategy, flood fill strategy, so I'll need to like give the direction vectors. And we are not moving diagonally. We explicitly state that we are moving like in up, down, left, right. So I'll just use that only. Okay. Yeah. So that's a flood fill strategy, guys. 0, 0, -1, 1. Exactly. So I'm doing the pre-computation, and for that I need to pass the grade here. So the grade will go on like, okay, 1 second. Yeah, I'm passing by reference. Okay, and obviously there should be like maximum row and maximum column for it. So can I say that I need to declare a certain bit of things here? Can I say that? So basically your m into n is your maximum row, so that's fine. uh can I pass the m and m also, like, yeah, that's better. Instead of declaration, just pass it because it is already known. Okay, fine. So we are done with that. Now we're saying that what we need, like component and component size. So what I do that, let's declare the component and component size here only and pass it. Instead of using like global also it will work, but then I need to assign it. That is not a, like, I will say a good choice, because like declaring globally, I should not prefer in general. I prefer to like pass it in main and then pass it as a function. So I'm just doing that. So vector of character, and I'll say like component. So basically it is a component ID. It will keep track of what component, like what component particular element, a particular cell is there. Okay, so it keep track of that. So I will like, I need to calculate for dot, but I need to like keep track of all, right? So I'll make it like m into n only. Yeah, although I need to like keep track for dot only, but I need to make like m into n. Okay, and yeah, that's a bit. And like initially all are like, if I starting the like component ID as 0, so I initially like no one is part of any ID, so I'll just make it -1. Yeah, for a bit. And no one else, so they can see I'm sorry. Come on, cut it, cut it, cut it, cut it. I'm sorry. Okay, yeah, that's a bit. Okay, guys. So that is your component. Now what I look for is that, okay, guys, so this is your component part of it. Now we look for the component size of it. So basically, it will keep track of like what is the component size. Like it is a part of component. So what is the size of that component? Okay. So I'll just like, and I'll say one thing, guys. This is a component ID. Why I'm giving a character, like long, it's fine, right? Yeah. Okay. So I look for the component size here. Yeah, obviously. And obviously the initial size will be 0. So we'll just declare it as 0. Okay. Yeah. That's it. And one thing is here also like character. Why do we need like we need that? Yeah. And now pass this to here. So that's a bit, guys. 1 second. Okay. Oh my gosh. What I'm doing? Like yeah. Find component. Okay. 1 second. A bit. Okay. Yeah. Okay. And we are given with the component size. Fine. So we declare the state that we look for. Okay. Now what I need that, what I do, I will initialize the current component ID. So let's say that current ID is your 0 because I explicitly say that I started here by -1. So I assume that 0 is your ID, component ID 0, component ID 1, component ID 2. We move something like this. Okay. And now I iterate over all the cells basically. So I'm just iterating over all the cells. Okay, yeah, because I need to find the component of it, like what is the component and what is the component size of it. Okay, yeah, that's what I need to find. So for the current cell, what I say that, okay, there is a one more twist, guys, because I am don't need to find the like what do you say? If it is a star cell, I don't need the component size of it, right? Because we are pre-computing for that. So what I do, I'll just skip it. Okay. So what I say that if the grade is star, okay, um, if the grade is star, oh my gosh, sorry. Okay. And one more thing, grid star plus you if you have already found a component, right? So because look, when you explore a dot here, or better to say here, when you explore this dot, you will also explore the neighbor of the dot of it, right? You also explore this dot. So component ID for that already get assigned. So something like that case, why should you need to find the component ID again, right? So just like basically ignore. So basically skip, right? So if component ID is not equal to -1, basically component ID already assigned, I will skip it. That's what I'm doing. Now I'm using the, like, what I need to do. I need to allocate the traversal frontier because for I need to use a BFS, I need to allocate the traversal frontier. Now look at this, guys. What is the traversal frontier here? Is it Q? Is it DQ? Is it priority queue? Hmm? Look at this. Here we are not mentioned anywhere the weight of the graph here. So since the weight is not mentioned by default, we assume that the weight is 1 means it's a non-weighted graph. So by default, the traversal frontier will going to be Q. Okay? Yeah. No priority, special priority we need to give. So by default, we traversal frontier going to be Q. And since I need to keep track of row and column, so I will using the Q of pair to keep track of row or column. Exactly. Plus, guys, since I need to find the component size of it, so it will need to be like I need to know that what is the like in current component, what are the elements is there. So for that, I need to like keep track of the current elements, right, in the component. So for that, I will keep track of the current element, and for that I am declaring another vector. I'm saying that that is a active wave. Yeah, so active wave is of like this. Yeah, it is a container storing the current component elements, right? Exactly. Now, after that, what I need to do, I am like here, basically you initialize the state for the current element. Okay, basically the initial element. Yeah, as we do in BFS, we initialize the state for initial element. So same thing I'm doing. So what I do, I will assign the current ID. Current ID already we know. So for a current element, I will assign the current ID, and that is your this. What do you say? Yeah, current ID. Fine. Apart from this, I will push in queue to explore. Like I will scheduling it to explore in queue. So that's what I'm doing. Q push IJ. Okay. Yeah. Now what I do, since here I do not need to track the layer, like basically certain count of it, just like in certain question I need to keep track of in which layer it become. In that I need to also maintain the layer count. Here we do not need to do. So I'll just going to, without layer loop, I'm going to explode the queue. So while queue.empty is not equal to true, basically until all the elements or all the neighbors is not explode. So first we check the oldest node, like oldest node first. So what is the oldest node? That's what we look for. So basically the T is your like q dot front. Yeah, this is your oldest node. I'll just pop it. Okay, fine. So this is get popped. Now another thing, guys. This is the front node already popped. Now what I need to do? I will explore the neighbors, obviously. And since basically, guys, this element is a part of active wave, right? Yeah, this element is part of active wave, and we explicitly told that it is not star, and it's not. It's the component ID is not declared it. So what I look for it, uh, part of ActiveWave. So just guys, ActiveWave dot post. Can I say that? Uh, RC. Exactly. Exactly. This is the element, and we'll just post it. Okay. Fine. That is another point, guys. Plus, uh, what I look for it is that basically now we are about to like we just need to explore the neighbors. Okay, so to explore the neighbors, what I need to do, since I am using the BFS here, I need to move in only four direction. So that's what, let it be, like just move in four direction. Okay, yeah. So let's say that nx is what you say r plus dxk, and y is your c plus dyk. Now since we are using the boundary BFS strategy, so I first need to check the boundary, that whether the cell is lying within the boundary or not. So if nx is greater than equal to 0, nx is lesser than the maximum row, that is m, and ny is greater than equal to 0, sorry, and ny is lesser than the maximum column, that is n. If this is the sense, this is the first thing, guys. So this is the sense here. Now what I need to do, that boundary is check. I need to check validity, that is the cell is valid. Okay, so when do you say that the cell is valid? um hmm? What do you say? When you say that the cell is valid, so basically cell should be a dot cell, right? I don't need to move, I don't need to go to neighbor that is a impassable cell. I need to go to a neighbor that is a dot cell. So that's what I look for, guys. Grade IJ should be, need to be dot. Exactly, that's need to be dot. Okay, now this is your validity check is also done. But guys, there is the condition here that I should only move to the unvisited cell. So is the cell is unvisited here? Okay, so that I need to check. How to I know that the cell is unvisited? So if the component ID is not assigned, I will say that the cell is unvisited, else the cells is visited. So cells is visited, I don't need to move. If the cell is unvisited, component ID, okay, sorry, yeah, IJ is not equal to -1. Okay, then I can say that the cell is unvisited. Okay, yeah, basically, sorry, it should be equal to -1. Yeah, so then I can say that the cell is unvisited. And if the cell is unvisited, what I need to do, guys? If the cell is unvisited, just assign the component ID to it and just push it in the like basically to traverse, right, in the script. Or guys, this is not IJ, this is NX NY, because we are moving the neighbor, right? So I am taking the current cell. Okay, yeah, yeah, fine. That is a bet, guys. So just assign the component ID here. So that's what we do. here just assign. Okay, what is the component ID? Just we assign the current component ID. Okay, yeah, as we already roaming, like current ID is this, so just do that. Okay, and we'll put it like this is a part of actwave. Exactly, so we'll push that also part of actwave, right? Exactly. That's it. Apart from this, anything extra I need to do? Like nothing I need to do. So this is fine. This is the only thing I need to do. Fine. Here we do not have a collision case, so we just have an unvisited case. So that is why this collision part they usually we see in certain question will not be explored here. Okay. Now, guys, I have let's say explored all the elements. I have the now in active wave I collected all the neighbors that is part of current component. So what should I do? I need to assign the component size to it, right? So for that, all the elements of active wave, okay, I'll assign the component size of it. And what is the current component size? What is the current size, guys? That is your active wave element size. Like whatever the active wave elements, number of elements is there in active wave, that is the current size. Like that is the current size of component. Okay. So I'm iterating over the active wave. Okay, basically elements exactly, and active wave is basically your pair. Okay, yeah, so let's okay, sorry, keep it as pair. Okay, because I just need to store the row and column, so that's what we're doing now. For the component size, okay, of the elements whose rows and column is there in active wave, their component size should be equal to current component size, right? So x.ft, x.sc should be equal to current component size. Okay, guys, that's fine. And now what I need to do, like since this for ID, for the current ID, for the current component, all the like current component size will assign to all the element belonging to the component. So the work is for this ID is done, just increment the ID. That's what I did here. Okay. So that's it, guys. In this way, our can I say that guys, can I say that the pre-computation thing is done, right? Exactly. So in this way, like for all the waves, I will able to pre-compute. Okay. Exactly. Okay. Yeah, so just call the pre-computation function here. Okay, so we have a grid here, fine, and we have a mn cells. I just pass the component here and component size, right? So our pre-computation thing is done. Okay. Okay, guys, so since we are done with the pre-computation, now my work is like I will move through the entire M cross N cell, not entire actually, basically through the star cell, because we don't want like if we have a cell as dot, we don't care. That's need to be dot. Okay, so what I do, guys, that I'm moving through the star cell, and basically I don't use BFS completely, like very short version, can I say that? Or basically not even a BFS. Okay, I just need to like explore the neighbors to it. Okay, and that is also the adjacent neighbor, because I already have the component size. Because if I find that the neighbor, like let's say that if the star cell, if it's find that the neighbor is just dot, right? So it already know the size for this entire cell, right? Yeah, since it already know the size for this entire cell, it will able to find the component size to it. So I will add to the current component, and then it will similarly by exploring all the star cells. Because if I make this, let's say this star cell dot, look at this, you will say that this 3 and this 2 is a part of one component. Exactly. And plus this also, guys, this. So overall, like, can you say that for this you are getting something like 3 to 5, 6, like somewhere like 7. Yeah, you are getting 7. Okay. So that is your answer here. Do you get it? something like this. So we have added all the component here. Okay. Yeah. So basically I'm just need to do that. And so for that I declare the answer. Question is telling that you should use vector of a string, but I will use vector and not vector of a string, vector of a string, so that will be faster. I'll use vector of character. Let's see if it pass. I don't need like worry because I'm more comfortable. I already told you with vector of character because that is I find easier to use. Okay, and initially all the cells are basically your dot. So let me do one thing. Let's initialize with dot only. Okay, yeah, and now I iterate over the grid. Okay, so that's it. Oh, 1 second. Okay, fine. Yeah. So this is we are iterating over the grid. Okay. Now we know that I don't need to check for the dot cell, so I'll just continue. If the grid IJ is your dot, I don't need to change anything. Like our answer already their dot I already declared in this initially, right? Initially in container answer, I already declared the rest will be dot. So no need, just continue. Okay. Now, if it is not a dot, it's a star, right? Okay. So that's we need to do. Like we need to explore the neighbor to it. So what is the current component size here? Current size here should be like initially 1. Can I say that? Exactly. Because in this component, initially I make the star now dot. So that is included. So current size become 1. Okay. Yeah. Now, what I need to do, I need to like, let's say guys, understand one thing that it might possible when you are moving neighbors, right? It might possible that two of the neighbors are actually part of same component. Okay, so their component id would be same, right? And so when I add like the component size to it, basically it gets double added. I don't want that, right? I don't want any duplicate elements, right? So for that I will keep track of the component id, unique component id, that is get added in the current component by changing the star to dot. Okay, so for keep track of the like component IDs, uh, keep track ID, I'll declare one container. Okay, now what I need to do, I will just explore the neighbors. Okay, I'll just explore the neighbors. So that's what I'm doing, and I need to move in the 4 directions. So yeah, that's what I do. Okay, right. So can I say that nx is your like what do you say, I plus the xk, and ny is your j plus dyk. Can I say that? Yeah. All right, guys. Now, for exploring that, I will use the boundary validity factor. Obviously, we are not using entire DFS. We are just like checking the neighbors. So I first need to check the boundary factor. So let's check that. For that, nx should be greater than equal to 0, and nx should be lesser than maximum row, and ny should be greater than equal to 0, and ny should be lesser than maximum column. Okay, yeah. Now the validity factor, when does the given cell is valid? If the create nx ny is a dot cell, isn't it? Yeah, that's what I mean we are finding, right? Exactly. So that is a part, guys. Now if it is a dot cell, there is a case, guys, that it's not we are checking the visited here. Here we are checking that whether the ID, the component ID for this cell is already part of the like already explored, already part of this container. That's we already discussed in early, that if two neighbors have same component ID means they are a part of same component. So why we will add the same component twice? that we don't want, right? So we'll use a flag to check whether this neighbor is not explored yet. Okay? Yeah. So this is some part of BFS only. Exactly. The case where unvisited. So we'll check because we don't know initially. Okay. So let's say the flag is 0. And now we are iterating over the ID, like keep track of IDs. Okay. And what I say that, what is the current ID, guys? Let's say the current ID is your grade, not here, component basically nx ny. So what I say that if current ID is equal to x, means my flag is 1 and break. That's what I'm doing, just break. Okay. So what I say that if means it is visited, yeah. But if it is not visited, if flag remains 0, then what you need to do? Add the component size to the current size, right? So what I did, current size, we have added the component size of this neighbor. Basically, part become the part of this component now, right? Yeah, and yeah, that is a one thing, guys. And post this component ID in this, basically this, yeah, so that it will not get like duplicate next time. Okay, so keep id, keep track id, push back. Okay, yeah, push back basically your what is id, like current id. Exactly. So that's it. For that we get the like current size to it. Now what I need, guys, I know the current size for the particular grid, right? Exactly. So what I do that, since I already know the current size to this grid, can I assign it? Okay, yeah, we did. So we'll just assign it. Answer I say is your current size. Exactly. And similarly we do for all. Now my task is just print the answer. Okay. Yeah. Uh-oh. What I'm doing. Exactly. So just what I'm doing this. Uh-oh. Yeah. Thank you for it. Without a space, right? Exactly. Yeah. Can I say? Ah. Why are you getting, guys, the characters? Why are you getting characters, guys? The reason behind that is like this is your integer, okay? And I have declared the answer as vector of character, right? Yes, yes. So I should like convert in character, assigning the ASCII character for 0 will get converted in the character, integer to character conversion. Yeah, then. Okay, here guys answer you get, but the overall question says that the answer is modulo 10. So we'll just assigning the modulo 10, right? Because here no modulo 10 is there, like answer is lesser than 10, so no need that. But